Hello, everyone. Thank you for joining us today. This is a deep set session where we're going to explore successful methods for getting your generative AI into production. I can see everyone is joining the webinar, so that's wonderful. Today, the webinar we are going to be presenting is From Framework to Production, Implementing Intelligent Document Processing, or IDP, with GenAI in Financial Services and Real Estate Transactions. My name is Ingrid Ramos, and I am a Director of Marketing here at deepset, where we make it easy to create custom AI applications to fit your exact needs. Like today, we're going to be talking about leveraging AI for lending due diligence. But before we get into that, a little bit about deepset. deepset combines our popular Haystack framework with deepset Cloud, our enterprise-ready platform to help you build, test, and deploy GenAI in your mission-critical business applications. Today's webinar is being recorded, and a copy of it will be sent to you following the webinar. Just some quick housekeeping. Please use the Q&A to submit questions throughout the webinar. We will also be monitoring the chat, but we have allocated time at the end of the presentation for Q&A. So that would be the place to do it. And then, yeah, if you have any questions, you can feel free to also use the chat. I'm going to go ahead and introduce our speakers now. We have with us today Mathis Lucka, who is our VP of Product here at deepset and a leading expert in GenAI implementation, focusing on building trusted, production-ready pipelines. Mathis will share deepset's proven framework for successful enterprise AI adoption. I'm also happy to introduce that we have Dr. Ralf Kauther. He is the CEO of credX, a digital platform where real estate borrowers and lenders can initiate, review, negotiate, and close high volume financing transactions. Dr. Kauther is a pioneer in applying GenAI to commercial real estate financing, and he's going to share credX's journey from prototype to production, including key milestones, challenges overcome, and a path forward. So with that, I'm going to go ahead and kick it over to Mathis.
Thank you, Ingrid, and welcome everyone. I'm Mathis. I'm very happy to speak today because this is one of my favorite kinds of webinars, the kind of webinar where we get to co-present with a successful customer, with Ralf and credX. And that's really, in so many ways, my favorite kind because one, I always like to see happy customers, and two, it's typically also the most interesting for anyone listening in because hearing a success story can inspire, it can give a lot of actionable insights and little tips and tricks on how to get to production successfully. And third, we have a very interesting topic that I'm very sure is interesting to many of you, using generative AI to streamline processes in financial services, more specifically in credit loan processing for commercial real estate. Very interesting topic. And I'm super glad that we have an expert in this field here with Ralf, who will walk you through the product. So what are we going through today? I'm going to share our AI implementation framework, really the most essential steps that we uncovered with many different clients on how to implement AI successfully. We will have a product walkthrough where Ralf will lead through the product that they implemented with us. And then we're also going to talk about measuring success metrics. I'm sure you'll all be very interested in that. And then we're going to have enough time for any questions that you might have. A bit of background for the company. I think it's always good to know who is talking, who you're talking to. I work at deepset. I've been here for almost 3 years now. I'm leading the product organization. And our mission at deepset is to help companies build AI applications. We started with that a little time before the ChatGPT hype. So the company was founded in 2018. It's backed by leading venture funds like Baldwin Capital, JV, Harpoon Ventures. We are headquartered in Berlin, but we are spread around globally, almost in the US and EMEA. And we've worked with dozens of customers in different industries on bringing AI to production. That's what I want to share with you today. All right. So this is a bit of a background. I'm only going to touch very lightly on that. But it's something that can all help all of you, guide you through an AI implementation process. Whether you're developing internal products or externally facing products, this four-step workflow is what we found to be most effective in ensuring AI product development success and kind of de-risking any AI initiatives. It's very simple. It's only 4 steps. And step 1 is you need to understand your user needs. You need to create a prototype with purpose. You need to iterate, get feedback, lower the barriers to adoption, and then you need to measure success. And to make this a little more lively, I will walk you through that. And actually, Ralf and I are going to walk you through that together with the example of the AI product that credX and deepset created together. So let me get into the problem first. What issue are we solving here? What we set out to build about 8 or 10 months ago was to streamline and accelerate the process of checking a big unstructured data pool of documents to make a financing decision for commercial real estate projects. So the challenges here are you have many different documents, from rental agreements to amendments of rental agreements to zoning plans to building plans to official documents from registries, environmental impact reports, and so on. And as a commercial real estate investor or a bank, for example, you want to decide, is this a project I want to invest in or not? Do I want to finance this project or not? And this is where credX comes in, and their analysts do an amazing job at structuring all of that data and creating a memo, sort of financing investment memo that gives everyone a very comprehensive overview over the most important factors that need to be considered when making this financing decisions. And challenges here, definitely data fragmentation, data scattered across multiple sources, thousands of pages across hundreds of documents. These documents are very inconsistent, very different formats. The whole process of gathering them, reviewing them is very time intensive. And then there's also a risk of errors, of course, human errors, but more importantly, typically you have one analyst really diving deep into this topic, and they are the expert on this project. And it can happen that there develops a bit of a knowledge silo, essentially, where only that analyst truly knows the project, and that's a risk. So we set out to streamline this process. We wanted to automate the time-intensive analysis, the collection of documents. We wanted to deliver a better experience for credit analysts to review documents, gather information, create these memos. And then, of course, it's very important to actually evaluate, are they faster? Can we process more financing requests, and that's what we're also going to share later on. So I think for everyone here in this webinar, you might have different levels of familiarity with AI in general, and maybe also AI in financial services. I'm going to share a bit of a background on the most important technological aspects of what we're building here before Ralf is going to walk you through the product in depth. From a technical perspective, what are we looking at here? We're looking at streamlining loan processing with intelligent document processing. Some of you might have heard of intelligent document processing, or IDP, already. It's essentially the process of using AI and other traditional machine learning methods to extract data from documents. Traditionally, you can imagine use cases like extracting a sales tax and an invoice total from invoices, extracting a name from a driver's license and doing that at scale. These are traditional intelligent document processing use cases. And while they can speed up traditional workloads tremendously, for our case, they were a bit too simple. It wasn't enough to just, I don't know, extract the rent total from a rental agreement, because the system we are building here actually needs to understand there's a rental agreement, there's an amendment to the rental agreement, there's a second amendment to the rental agreement, and in the second amendment, we actually agree to a new rent, so the amount changes. So it's not enough to just extract that one data point. The solution actually needs to reason over the data. This is where the second technology comes in, which is RAG, or Retrieval Augmented Generation. I'm sure many of you have heard of that. To sum it up, essentially it's you have a pool of unstructured data, text data, can be hundreds, thousands, millions, billions of documents. And you have a large language model that can review data, can reason over limited amounts of data, can give you answers to questions, it can extract insights. But it can only do that for part of the data. So you need to identify which parts of the data are actually relevant to answer a specific question, for example. And to do that, you add a retrieval component, a component that fetches data based on a question or an insight you want to extract and gives that to the LLM. This improves accuracy. If you would just take, let's say, ChatGPT and ask it about a specific commercial real estate project, it would probably hallucinate, because this is private data. This is nothing that the model has ever seen during training, so it can't know about that. If you feed the data into the model, it's actually going to give you sensible answers to your questions. It also helps to continuously learn, essentially. You can always update your data pool. You can always update how you fetch data and bring it into the model, into the prompt. And this way you can basically rapidly analyze data with a large language model that only you have access to. You're kind of customizing the LLM for your business. And these two technologies, IDP and RAG, is what we brought together for this use case. So reasoning over a large pool of documents to extract insights. Now, in terms of challenges, we ran into a bunch of them. And for anyone embarking onto the journey of building an AI product, I can assure you that you will run into challenges. They're all manageable. Among the challenges that we faced were that we had thousands of pages per real estate project. We didn't just want to extract data points, as I mentioned. We wanted to reason over the data points. All of these documents had very different structures. Some of them might contain tables. Some of them might contain handwritten notes, like we have rental agreements where people check boxes in a handwritten fashion, and then later the document is scanned, and our process, our system needs to understand which boxes were checked. We have zoning plans, for example, so sort of like images that we need to analyze. So that was definitely a challenge, handling all of these unstructured documents. And we also needed to make this process faster than a manual process. So that was always our North Star. How can we enable the credit analyst to create a financing memo faster, way faster than before? That was always the North Star and what we needed to keep in mind. While at the same time knowing that there's no way at this point that we can fully automate the process, because we're making high risk, high value decisions here. We want to speed it up, but we're not at a stage where we can fully automate it. It might come in the future. Right now, the value creation is just in speeding it up. So how did we solve these challenges technically? We started with a pretty complex document processing pipeline where we are performing document layout analysis, OCR. We're actually using a large language model to extract metadata, generate new metadata that really helped in identifying relevant documents, also the relationships between documents later on. And then we had, for the retrieval part in RAG, we had the challenge that we always wanted it to be very complete, let's say. In a commercial real estate project, you can imagine it's very different from a Google search. If you do a Google search, you're asking like, I don't know, what's the capital of Germany? That's Berlin. There's one answer. Easy. If you have a commercial real estate project and you want to ask, what's the surface area of the property? We have cases where a due diligence document says it's 50,000 square meters, and then in the construction permit, it actually says it's 52,000 square meters. So there are different answers about the same question. The analyst needs to know these two different answers. They need to see, oh, we have a construction permit that says this. We have a due diligence report that says this. We have a rental agreement that says something else, or ideally it says the same. These things need to be surfaced in the process. So this is why we can't just identify a single data point. We need to find all of them, everything that's relevant for a specific insight, data point, or question. So these were among the challenges which we tackled with a very sophisticated retrieval approach, and then a kind of multi-LLM, multi-agent, multi-generation step. In terms of architecture, I'm only shining a brief light on this. I think the message that should come across here is typically people think about models. They think about GPT-4. They think about Sonnet 3.5. To make any of these usable in the industry, in any industry, you really need to build a system. And that's the system that we've built. We have the credX data platform. where we have a data room with all the documents, and we want to have the results there, the memo. We have in our backend deepset cloud where we accelerate the development. We have OCR, we have a document processing pipeline, we have data storage in form of a vector DB, we have a retrieval process, we have many different generative models actually we're using. And then we have a front end, of course, where the analyst can review the results, pick relevant data points, and create the memo that can then be exported. So that's a rough architecture. And that's also where we get into the interesting bits. That's where all of you get to see the product. And I'm going to hand it over to Ralf here, who will walk you through what we've built.
Yeah, thank you, Mathis, and welcome everybody. Very pleased to show you now how the system looks like and how we will use it in our everyday practice. And Mathis, you already explained quite a lot, and you already said a lot about the process, which was very important. And yeah, now the challenge is me, I must say, to give you some more flesh and color to put it into to put into the presentation. So as Mathis already explained, our business challenge is to analyze carefully a bulk of documents about multi-million euro real estate transactions. By that, we write a standardized memo and presenting all relevant information to the lenders that we address on our platform. And we typically start, as you can see here, we typically start with a data room, 50 to 100 documents, around 1,000 pages. These documents are delivered by the borrowers. In the middle, you see the data room, and this is according to a comprehensive data collection sheet and stored in this data room. Then the result is a comprehensive and ideally error-free financing memo of 8 to 12 pages. It's basically a data set comprising 200 key value pairs and a few explanatory text boxes. That's what we extract from this data room, from these 50 to 100 documents. Needless to say, it is of utmost importance that the information contained is both accurate and comprehensive. And now traditionally, an analyst will open our memo template and see these 8 to 12 pages, these hundreds of fields. We'll stay here on this slide for a moment. And then he will dive into the data room. She will then start working on the sections of the memo, which are called rent agreements or descriptions of the financing object. And in fact, she will fill in tables. Thereby, she will read dozens of documents and develop a deep understanding of the financing request. She will make notes and from time to time insert values in the respective fields of the memo and make comments. She will iterate on some issues and go back to the borrower and fetch more information. And this whole process typically takes 5 working days for one analyst. And as Mathis pointed out, it's important that this is one analyst that is doing that and that concentrates the whole understanding of this financing memo in his brain. And typically this consumes 5 working days and can easily stretch over 2 or more weeks' time. And now we have Danny Wee, which is our virtual assistant. This complex and knowledge-soaked process is facilitated by Danny Wee. As Mathis explained, it's a front end, as you can see it here, connected with the credX platform on one side and the deepset cloud. We developed it together with Faki IT. These are very capable and customer-oriented software engineers, but it was also very important for us that they know the deepset cloud very well so that we have no frictions between front end and back end. I will show you Danny Wee's main functions with screenshots. We work with real data from past transactions. Apologies, they're in German since we are currently active in the DACH region. Can we go back, Alan, and let's leave it on that slide. Thanks. But we have included translations where appropriate. For developing the pipeline, by the way, we don't need this front end. That's only for the work of the analyst. For developing the pipeline, and that was very important, we can directly work with the real data in the deepset cloud. And now with the front end, it's rather straightforward. You see each transaction has its own workspace. Here on the upper left, we give it a name like a Nahversorger Köln, which is the name of this transaction. And in the first section below, we prepare the queries in the preparation section, and then we go on, we run the queries, we analyze this information, the files that we have prepared. Normally this takes 2 to 3 iterations, and then we need to go back to the borrower and fetch some more documents. And as we go on, we can export the current results as an XLS file. This is done in this export section. The structure of the files doesn't matter. If you look, it's simply a data room used. And if you see here, I don't know whether this can be seen. Can we move one slide forward, Alan? Thanks a lot. And as you can see here, this is the typical nightmare of an unstructured data room. For example, this document, which is named TBPB 200129, miraculous document in the data room. This file can or cannot be machine readable, and normally it takes a day to manually screen such a data room and familiarize yourself with all the documents contained. And now DanyWe does this in minutes. It's done by these metadata. The system extracts without us doing anything. The system extracts these metadata. It gives a short description and makes the documents machine readable automatically. And we have a classification system. You see the translation here. So this is the floor plan. We see what is contained in the document. And we also have a classification system. So we get a category and a subcategory. And we can use these classifications to organize it again to reorganize it into files as we like it and according to any scheme. Of course, this is our own classification scheme, but we could easily implement any other classification scheme and feed it into the model. Now let's go into the document view. The analysts can also preview the document, and you see here it's as the model rightly has detected in the metadata. It's a floor plan, which is again, of course, an OCR nightmare, but the OCR, the pipeline, the model is able to work with this document. So this is the file section. We have all the files here, machine readable and tagged with metadata, and we can review, we can have a preview on the slides. We can select the relevant files. Normally this will be between 50 and 100. Then we go on and select questions. So that will be on the next slide. Yes, we can start the Q&A process, and then we select the questions. The next slide. We see quite a number of questions, and I will show you a translation of these questions. And after preparing the slides, we progress to the analysis. We select the questions. They stem from a standard questionnaire of several hundred questions, and we take out, let's say, in a normal transaction, 150, which are appropriate for this transaction, and then we can fire it on this on the files. Let's have a quick look at the translation. This is an extract from the question list, and here you can see that these questions are covering all the aspects, all the different aspects of a real estate transaction. So it starts with building rights, leasehold rights, the more legal aspects, to the business aspects, investment costs and rents, up to very detailed questions about the building, like heating and building materials used. And all these questions, they help us when we are firing these on the files. They help us to fill in the relevant boxes in the memo. So we then select the files. On the next screen, you see in DanyWe, we can easily select the files. We choose which questions and documents we want to include in the next query. The system, and that is very important for us, can handle extensive questionnaires and a large number of files. So normally it's easy to ask one document 2 questions, but it's not so easy to ask a bulk of documents, let's say 50 or 70 documents of more than 1,000 pages, 150 questions. That's quite difficult. For an initial run, we will normally take all the questions and throw them on the entire data set. Why is that so crucial for us? Because it wouldn't be efficient if our analysis had to select files themselves. because then the analyst will tell us, okay, if I have to select the files myself, then I have to run through all these different files, and then I can do it the traditional way. So it's really important for us that to follow our North Star, to really save time, we can handle large volumes of data and also tackle them with large number of questions in our standard questionnaires. Then we start, once we did this selection, we can start to process the answer. That will be shown on the next slide. The AI is now processing our request. That will take a few minutes, and for 150 questions, it might take half an hour, but this is no problem for these batch runs. Of course, individual questions are processed within seconds. Then we get an overview about all the questions processed. We can see it here, and the green questions we have already reviewed and approved, and the gray questions are still open, and then the analysts will dive into a question. So let's select one question, for example, this question about the lease term. This brings us to this is the screen where our analysts spend most of the time. Here they review the individual answers, select the relevant ones, and derive entries for the memo. I'll first explain the workflow using screenshots, and then, since this is the area where AI shines brightest, I will also present translations of the screenshotted content. This will help all of you to understand how well the system interprets, or as Mathis puts it, reasons over complex text. And that is important. It's not only data extraction, it's not only finding the needle in the haystack, it's about reasoning about all these texts. The analyst sees the answers. Typically, it's 5 to 15. In this case, it's 16 answers. You can see 4 of them here on screen and can verify them directly. The system has already sorted this answer by relevance. So it's important for us that it gives us this whole menu, this whole array of answers, since we don't want to miss something. But it's also important that it has the ability to rank these answers. Now the analyst can go and verify the answers directly. He will do this by diving into the reference. And that's the next slide. So he will simply click on the answer, and then he will get the reference for the answer number 1. This is a tenant list. And the reference for for number 2, this is on the next slide. This is the source here is an addendum to a rental agreement. And the reference to answer number 3, this is, surprise, again, an addendum to a rental agreement, but for a different tenant. So now let's look at the translations that I can explain and demonstrate better how well the system works with these texts and how deep the, let's say, understanding or interpretation capabilities of the system are. So the answer which is given for the query, what is the lease duration, the term of the financing object, is answer for local supplier 1. So he differentiates between the two suppliers for local supplier 1, and he gives a concrete lease date, and he also the fixed lease term ends in 2036. And then he continues for local supplier 2, the lease start date is 2021. And we see these are data all comprising already displayed in this tenant list. The system has thereby achieved an impressive result. As you can see, of course, the table is not very big, it's straightforward, but it needed to correctly recognize and process the entries, which is not at all easy. Previously, this would have required extensive training on specific tenant list formats. Today, models come equipped with these capabilities, though it's still important to know how to leverage these abilities, especially since many Excel files remain unreadable in most applications. Maybe some of you tried ChatGPT with an XLS file. Normally, it will not work, or it works only since for a few days or weeks now. This has been a problem, and this also has been a problem for our pipeline, one of the many problems that we have overcome. However, our analyst will surely not be fully satisfied with the result, because the tenant list could be outdated or incorrect. So he will move on and also verify the answer number 2. So let's look at the translation of the answer number 2 on the next slide. You recall it's the addendum to a lease contract, and the answer here is straightforward. The fixed lease term begins upon handover on 2021 and ends in June 30th, 2036. So this is exactly what we already knew from the tenant list. So this is highly plausible, and we can move to addendum 3 now. And we can, this is the document, so we can also verify it in the document itself. We are led to the document by one click. And now question number 3, again, a lease term is given, this time for supplier number 2, and the source is the addendum, the latest addendum, the most recent addendum to this contract. And please remember, the system doesn't just achieve this for one rental agreement, but across thousands of diverse documents. Yeah? Training a graduate student to perform at this level would take us more than a year, because this is not an easy cognitive operation. This means the system had to select the correct most recent addendum. It also found in the data room several other tenant agreements, contracts, and it did pick out this most recent addendum. It had also to discriminate between the two suppliers, because there are two rental contracts, one for one supplier and the other series of contracts and addenda for the other supplier. So it had to understand that we are dealing with two suppliers, and it then extracted the exact information and pinpointed it in a very concise manner, as you have seen here. So at this point in time, the analyst will be satisfied, and he will then move on to state facts. The analyst can save these relevant facts. That's on the right side. He now has verified the answer, and then he will go on and he will mark the answers as relevant, click on the answer and move it to the right. Then we have these references at the bottom of the right side. So the system then automatically logs the references and displays the sources. And the analyst will then, by copy and paste or by simply writing a few numbers, he will then insert this fact value after having selected the appropriate fact. So he has a list of 100, or as I said, the memo contains 200 facts. So he has a list of 200 facts. He selects the relevant fact and he just inserts on the right side here this fact value, and then automatically the resources, the references are made and the sources are given. And this again can be exported in an Excel file. Yeah, we wanted to have this most flexible, so we use an Excel file here. We screenshotted it on the next slide. This is what we call our note. We can skip these. I also have a second question, but it would now take too much time. So let's skip this. I think you got the story, and I hope I was able to convince you how capable this system is. So we can now, once we have selected the facts, we can export a working paper, and this working paper will, in an Excel format, display all the relevant facts, and it will give, as you can see, I can extract here some lines and show these lines, and then it will also give to each fact, it will give the relevant reference, and we can link it to the relevant source. And that means not only when we do this memo, when we generate this memo, but also when we deliver this memo together in the future with this working paper, then also our clients, the banks and the lenders, benefit very much, because now they get this extensive working paper, which makes all this doing all these findings of the analysis of the analysts very transparent and easy, much more easy to digest. Okay, so a few concluding remarks. We are not done with the system. The productive version will start in 2025. We will have to do some refinings in the back end, and also we have to implement the front end, but I don't think this will pose much difficulties. It's only a questions of some weeks, then we can roll it out. The system then is fully scalable and deployable on the AWS cloud via the deepset cloud. And, which is important, we will also have ongoing improvements. So of course, January will not be the end of the story, but we will then identify new LLMs as we do it now. We will identify new, together with deepset, new framework components, discuss with deepset how we can improve the pipeline, and then move on to make this better and better. And we achieved a lot of our ambitious goals. And what is even more important, we even got a lot on top what we had not on the agenda when starting this project. So we started this project we started implementing it in no sooner than in June this year. And our plan, as we discussed it prior with deepset, was to save analyst time around 30 to 40%. And yeah, that we will achieve that. We are pretty sure right now that we will achieve that, because as you see now, this process saves significant time. Instead of repeatedly reviewing documents, the analysts can now focus on reviewing answers, and all the references are made automatically as they go on and analyze these documents together with their, let's say, virtual colleague. Reviewing 150 answers, of course, still takes about 5 hours when we do it that way, but we are down from 5 days of manual work. This is these 5 hours will not do. This is only the initial run. Then we will have follow-up runs. They are still required. We will have we expect a few challenging questions where we still have to dive deeper into the documents. However, even in these cases, machine-readable documents and the ability to query them will help the analysts immensely. So we are down to 5 hours for the initial run from, let's say, 2 days, and then we have some more days, and we are pretty confident that we can go down from 5 days of manual work to a maximum of, let's say, 3 days, which is a very big achievement for us after only 6 or 7 months project time. The ROI, well, that's simple. Each analyst if we save 30 to 40% analyst time, we save approximately 40,000 euro per annum per analyst. So that means it's a huge ROI, of course, if we pile all these savings up. And we also expect improved returns, since the memo quality improves, the documentation improves, all these references will drive more business and also justify higher prices. And last but not least, we get also unexpected benefits. The system flexibility allows us to adapt it to other tasks beyond memo creation by simply adjusting the questionnaire and the working papers. So for example, if you're from the real estate industry and you want to do transactions, you have to make an investment decision, of course you also have to review these documents, and we can simply take a different questionnaire, adjust our questionnaire a little bit, test the question, and also do the working papers as you like them, as you can digest them in your system. And then we will have a second pipeline derived from our current DNV pipeline, which is capable of handling your work, your use case. Therefore, we decided to expand our business model. This was not on the agenda when we started it, but now we saw that it works so well that we will also expand our business model. We will offer DNV to third parties, for example, to lenders or to real estate companies, or to valuation, for valuation reasons, valuation use cases, and we can use we can offer now this document analysis as a service. and companies that cannot or want not develop, operate, and maintain such a system themselves can implement state-of-the-art document analysis within weeks or even within days, because the pipeline is ready, the front end is ready, and it can be adopted to your use case. So let's end it here. I could also talk now some hours about key learnings. As Mathis pointed out, this was not been an easy process. It posed numerous challenges. We have overcome them and we learned a lot. But I think you also, I hope you also already learned a lot. And I want to give you now the opportunity to pose your questions. Thank you very much.
Thank you both so much. Really appreciate it. I'm just going to launch a quick poll while we are looking through the Q&A. There's several questions here people post in the Q&A. We also have a few in the chat, so we'll go ahead and get through those. If you can answer the poll on the screen, that would be wonderful as well. So thank you to Mathis and Dr. Kauther. We do have a question here. What are the benefits of using a framework when building with AI? Mathis, perhaps you can take that one.
Yeah, I think the main benefits when working with us, when working with our framework from prototype to production, from framework to production, essentially is making sure that your generative AI project succeeds, that it actually delivers value in a timely manner. You're not just playing around, you're taking action with AI, like credX did. And it really helps you at every step of the way identify what's the most important thing right now. How do we get to our goal, and how far are we off? And then iterate to get there faster in the end and get to better results. And this is backed by our platform, deepset Cloud, which allows this style of work, which is very helpful, both in terms of total cost of ownership of building a solution like that, as well as in accelerating and making this workflow possible, essentially.
Great. So we have several other questions here in the Q&A tool. Mathis, if you want to take a look at that, I'm going to pull a couple of them. Can analysts provide feedback to the system by indicating the most relevant answer? And is this used to train the RAG database?
Yes, so feedback was very important during development, definitely, where on deepset Cloud, you can easily give feedback. And then once we move into production, the implicit feedback of what was actually selected and which references will be gold in improving the system, because of course we can track that across hundreds of transactions, which data points were the relevant ones, from which sources, what other things do we present to the analyst. And this can be used both to validate the quality as well as to improve the system further down the line. So yes, both during development and in production, feedback will be essential.
Great. I have another question here about the time savings of the analysts. I guess, Ralf, this would probably be for you. You mentioned a change to your model. Is it your billing model, or how has this impacted, your business model?
Yes, as I said, we save 30 to 40% analyst time, and and of course this is a different process for the analysts. So it was important that we have the analysts on board here. The traditional process is they read documents, they have a certain section in the memo, and then they read documents, and they develop an understanding of these documents. And then they will go again and again in the documents and retrieve the information and compare it to other documents. And now they have to go through these questions. And this is different, but this makes up the time savings of 30 to 40% because the system is more capable in screening the documents and in extracting the possible answers and also in making the references. So as I said, 40% of analyst time, and we expect to go further on, maybe in that framework, with that process to 50 or 60%, and then in a further process, we will move on because we already foresee that today this is an assistant to the analyst, and one day it will be a more fully fledged analyst, and one day maybe a superhuman analyst, which is better than at least most of the analysts. And yeah, that's was the first part of your question, I think. I missed the second one, Ingrid, to be honest.
Yeah, I think you got to the point. I think they were kind of interested in how is it impacting, your billing and how you're presenting.
The business model. As I said, we were able now to take our business model on a second pillar. So far, we are, so to speak, a company bringing together borrowers and lenders. And now we will also be a kind of software provider. We will provide this document analysis together with deepset, powered by deepset, as a software, so that companies can also take this service from us and not only our core product.
Thank you. Mathis, if you see any questions that you want to bring to the top, let me know. I see a couple that I can also deliver to you.
Yeah, I think we have many questions on the data format, on images, on OCR, and maybe I can kind of answer them all together. So yes, OCR is a very big part of this process and the system, and it was important figuring that out. We are using, on the one hand, OCR, including document and layout analysis, where you can find things like this is a table, this is a heading, this is a paragraph, and then get the text from there. But then we still have figures, images, where we can use a visual language model to describe what's on the image. That makes it retrievable. And then we can also, or we are also using the LLM to add additional metadata during post-OCR, essentially, which also helps with identifying the right documents in retrieval. And then the visual aspect, we can also pass visually to the LLM so that it can see what's on a zoning plan, for example. So it's a combination, multimodal extraction, multimodal retrieval kind of, and then multimodal generation, because we have such a diverse data structure.
Okay, yep, there was a lot of questions on unstructured data, so thank you for taking that one on. There's also a great question here on accuracy and how we ensure the system doesn't hallucinate. So perhaps more about our groundedness score, or can you elaborate on that, Mathis?
Yes, so we have different tools to ensure accuracy and avoid hallucinations. I think one part of the question, or one of the questions I've seen, is RAG kind of being capped at 65% accuracy, vector RAG. And this is maybe, I think anyone who's interested in a more technical deep dive generally on building these systems, please reach out, schedule a call with us. But overall, what we're doing essentially isn't just vector RAG. We mentioned the very complex data preparation, metadata generation, this is incorporated, that gets the accuracy up. And then we're using an iterative kind of agentic retrieval where we're not using a one shot, like, hey, retrieve relevant documents and that's it. We're kind of using the LLM multiple times to decide, okay, do I have something in this category? Do I have something in this category? Is there anything else that's relevant? And this way we can get much further and much higher accuracy than just with a plain simple vector X solution. And for hallucinations, we have on the one hand a groundedness score that measures hallucinations. On the other hand, of course, we have the human feedback, people reviewing this, people looking at, is this accurate? And overall, what we found again and again, not just with credX, is if you get the right data to the model, it's going to use that data and it's not going to hallucinate. If you don't get the right data to the model, then that's where you might be in trouble. So we're first and foremost ensuring that we're getting the right data to the model, essentially. And then there are other precautions you can take against hallucinations, but I think would be a bit too much to discuss them all right now.
Thank you, Mathis. Yep, great follow-up questions for after the webinar as well. I did want to also highlight this question on, can the system be used with various languages, right? So not just English. And I think this is a good example of how we've got German, but can someone elaborate on multiple languages?
Yes, I can do this. I think we can do it with multiple languages. So the reason why we didn't it here is that we don't have this extensive document database. So we need real life transactions in English, but then it would be no problem. The system certainly understands English and also other main languages, and we can then even use a German questionnaire and then work with English documents. Ingrid, I also saw two other questions that I might elaborate on, because this they go after some aspects of the presentation. So one, somebody is asking here, how is this final value entered in the Excel? In the example with the days, does the analyst fill in the data manually after reviewing the 16 answers? No, he has this screen, and in the screen he has on the right side this fact section. So he will take the relevant fact, and then on screen in the DNAV system, he will go and take the relevant questions and simply move them to the sidebar, and then these will be marked as references, and then he will put in, by copying and pasting or simply typing in the number, he will also put this fact in DNAV, and then all these facts that we have gathered in DNAV will then be exported in the Excel memo. So no extra work to write them in an Excel memo. The facts are gathered in DNAV and then exported to the Excel memo.
Great. Well, I would like to say thank you so much. I really see so many questions here in the Q&A, and we're not going to get a chance to get to them all live. If you have a question that we didn't get to, we will try to circle back with you, but feel free to follow up with us. I did want to leave you with some parting thoughts, including thanking you for the polls. I'll go ahead and share some of these results right now. I wanted to thank everyone for joining us today. I know time is very valuable. We have some resources here on the screen to learn more. We also have been named a Gartner Cool Vendor in AI engineering. So we have a link to the report that will be complimentary for you. It is the Gartner report. Some great recommendations and findings in that report, as well as some vendors. So those are the resources we have here. And again, if you have additional questions, you can feel free to follow up, and we will try to route those to Mathis or Ralf. Be sure to check us out. We're going to have some more webinars coming up. Follow us on our socials. And again, I wanted to thank our speakers, Dr. Ralf Kauther and Mathis Lucka, for joining us today and sharing some of their findings. And we hopefully will be able to see you all very soon. Thank you and have a good day.
Thank you, Ron.
Thank you.